Hi everybody. What we got here is an old Carter rotary converter, or rotary inverter if you prefer. I found this on eBay and it was advertised as used and untested, and as you see, it's fairly tired and dirty, although I've already cleaned it up a little. The seller, being a very reasonable person, had put a fairly low price for it. Actually, the shipping cost ended up being 4 times as high as the item price. I assume that this item was really untested, not something that he knew didn't work and just tried to get rid of it. When an item is listed as untested or sold as is, and in addition says no return, a seller doesn't take any responsibility, and by bidding and buying you agree to these terms. So it's always a risk when you buy something that's claimed to be used and untested. The item may as well be a defective piece of junk. But this seller had very positive feedback, so I took the chance and bought it. Well, I was thinking of this as mainly as a project to study and perhaps do some experiments with, regardless of the condition. If we take a closer look at the nameplate, it's scratched a bit. I apologize if the camera can't focus properly, but what it says, input is 28 volt DC, rated amps is 38, and the output is 115 volt AC and maximum 6.3 amps. When I saw 28 volts, I was immediately thinking about aircraft. So this unit may have been meant to produce 115 volt AC at 60 Hertz on board an aircraft. As you see, 3 out of 4 of the feet were broken during the transport. This was a bit unfortunate, but this is something that may happen. If it was bolted to a thick piece of wood, this could have probably been prevented, but I didn't find any reason to complain about it. The box may even have been dropped during the transport, so it is what it is. Apparently, Carter Motor Company is still making rotary converters like this, so I'm asking them if they have a foundation bracket which comes close to this one in size. If I need to trim it a little to make it fit, well, that's fine. At the same time, if they have a handle which is also broken here, that would be great. The old one has smoldered up for a long time ago. Okay. As always, when you buy a used and untested piece of electric equipment, it may be good to take a look at the condition before you decide to power it up. So I took a peek inside to check this one out. So I removed the end covers, and let's do that. There we go. Let's put my little light on here so we can take a better look in here. When I checked it out, obviously this item has been stored for a very, very long time, perhaps even a few decades. It was even some cobweb cobwebs right here. So yeah, but still it's remarkably clean inside. The only thing I did was to just wipe off some white dust here, and inside here I saw some, at the bottom here I saw some thick layer of white dust, and immediately I got worried, is this a sign of water ingress? But apparently it was just loose dust, and that would have been shown other signs inside there as well. And as you can see, yeah, it's not easy to, yeah, you can see it's a bit, it still has a layer of white dust. I haven't cleaned away yet. And by studying the commutator, I found there's absolutely no evidence of grooving. It has a slight patina on the commutator, which is good. There are no burnt or pitted commutator bars, and let's take a look. Yeah, see that little hole there? There are a couple of those. They caught my attention because I was worried if windings had been shorted underneath here somewhere. That could obviously create something like this, but using cotton buds around there, I tried to clean it up, and there was no debris or anything that would be consistent with burnt or shorted windings under here. Next thing I did was to take a look at the condition of the carbon brushes, of course, to see how heavily used this item was. And see, you have the brush caps. They are fairly large. They are designed to be unscrewed by using a quarter, but that was not possible. They were completely stuck. And yeah, so I had to use a pump pliers so to loosen it up, all the four of them actually. And be very careful if you encounter that on the DC motor with the brush caps like this, if they are stuck and you need to use a plier to loosen them, because they can be brittle and easily break if you are too hard with them. The springs are quite strong here, and this is a fairly beefed up size carbon brush, obviously made by graphite. It has a wear mark, and the surface going against the commutator is nice. There are no chippings or anything on this, so they were in good condition. When you install back the brushes, always be sure to install them back in the same position as you took them out. Let's see. Let's put the camera here, and a little fiddly to put back in place. There we go. So that was the motor side on the converter. Let's move to the other side and have a look at the slip ring side, or the generator side of this. Now this is, here you see the slip rings. They are also in the same good condition. The plate you see here, that's the back side of the cooling fan. Now, what really caught my attention when I checked the brushes on this side, you see the brushes on the high voltage generator side, they are a lot smaller. And I'm not sure how well. Look at this. Only half of the surface has actually got the curvature of the slip ring. The darker side has not even been in touch with the slip ring yet. So these brushes are still bedding in, and you see the wear mark. So what we really have here is an item that has barely been used. Okay. Put this back into place. Always a little fiddly to get those clips back inside properly. There we go. And yeah, and these are actually the brushes that which were put in place during the manufacturing. It's very clean. There are no carbon dust anywhere inside it, so which is consistent with the very little use of this item. The converters made by Carter, they came with different features. Some of them had a little frequency meter and some electronics inside was to adjust the speed so that you can fine-tune the frequency. Other they had some sort of circuit to detect load. They had one outlet here and one in front, and a selector switch. The outlet in front was marked for refrigerator, and the way it worked was, if the compressor in the fridge were not engaged, the circuit was still open, the converter didn't run. But once the thermostat kicked in, the converter started, and it detected that the circuit was closed, and the converter started, and then the compressor in the fridge. And the other selector was if you switched the fridge outlet off, it would be continuously running to hook in other items like appliances and smaller power tools. Inside this box, depending on the on the features and what it is meant for, you could find filter capacitors. You can find sometimes coils to smoothen out the sine curves. Let's pop up the hood and take a look here. Well, this model, not much. A lot of empty space. There are 3 or 4 filter capacitors on the inlet here, and also the one for the or input for the output, probably to filter out then the radio interference which may occur from or be created by the brushes. Well, in this model it's not much. There are some other holes here and some like ditches here, obviously meant for other components depending on the outfit and the features of the converter. Now let's power this thing off, see how power it on, and see how it runs. I have a power supply. It's a 24 volt DC, but there is a little fine tuning pot meter in here. You can crank it up to 26.9 volts, which is sufficient. When you receive an item like this, you have never hooked it up before, and it's the first time you test it, always be sure to include a fuse in the circuit. This power supply has a short circuit protection, an auto fuse, so it was fairly safe, but of course you never know. And also, if you connect it to a battery without a fuse, well, you may encounter some unexpected fireworks. So let's power it up. Take a close look at the commutator, and there we go. Not even a tiny little spark from the brushes, even during startup when the power consumption is at the highest. So the commutation conditions are excellent. And no singing or whining from the bearings. There is no lubrication point, so these are shielded ball bearings inside, which do not require maintenance at all. They'll need to be replaced when they're worn out. Okay, let's take a look at the output. Let's put these two DC voltage is 123.6, a little high, but it's acceptable. It's important to keep in mind that this item is running unloaded, So with a little with load on it, the RPM will slow down a little bit, and the voltage would be more would be closer to the rated voltage on the nameplate. And let's measure the frequency. 69.4, that's way high. But again, it's running unloaded, so this is to be expected. And those converters without any means of controlling the fine-tuning the frequency, that's how it is. That is to be expected. So that's it. What I thought was really, or expected to be a piece of junk, appears to be a barely used item. Technically, this is as good as new. And I'm gonna shine it up, probably clean it, give it a good cleanup. Repaint using the same paint, crinkle finish paint as the rest of it, and make it look good again. And then I have a very good converter. Okay, thanks for watching.